Hello everyone, welcome to this particular module and this particular lecture of these combinational circuits. Today we will discuss about decoder and encoder. What is a decoder? So this is the basic block diagram of a decoder circuit. So a decoder is a combinational circuit that converts binary information from n input lines to maximum of 2 to the power n output lines. The encoded information is presented as n inputs producing 2 to the power n possible outputs. So the 2 to the power n output values are from 0 to 2n minus 1. Okay, if there are 2n output values, then it is ranging from 0 to 2n minus 1. So a decoder is provided with enable inputs to activate the decoded output based on data inputs. When any one enable input is unasserted, all the outputs of decoder are disabled. Okay. So we have here a binary decoder, 2 to 4 decoder. We have two input A and B, and we have four outputs Y0, Y1, Y2 and Y3. That is why we are calling it a 2 to 4 decoder. So binary decoder, it has n bit binary input and one activated output of 2 to the power n outputs. Alright. A binary decoder is used when it is necessary to activate exactly one of 2n outputs based on the n bit, based on your n bit input value. Alright. So, if you see here, this is the 2 to 4 line decoder. So, how we are forming it? With two input, 2 to 4 line decoder will be having 2 input and 4 outputs. So you can see here, with 2 inputs we can have 4 combinations, right? So when the enable line it is 0, when the enable line is 0, the input is don't care. Okay, input can't be defined. It can be either 0 or it can be either 1. So in that case, even if it is 0 or 1, output will always be 0. Now, in order to get the output, that means in order to enable your decoder, we have to keep the enable signal always high. 1 means high. So with 2 input, we can have 4 possible combination. So what are those? 0, 0, 0, 1, 1, 0 and 1, 1. When both the inputs are 0, 0, output will be Y0. When A0, B1, output will be Y1. When A1, B0, output will be Y2. And when both A and B are 1, output will be Y3. Okay. Now, if you, whenever you are getting the 1, so accordingly we have to get the logic diagram. Y0 means A0 bar, B0 bar and enable, that is the AND operation. Okay, so first we will make a input line for A, then the inverted input line for A. That means if this is A, this is A bar. Then this is, if this is B, this is B bar line. So Y0 means A bar into B bar and E. So A bar, take a line from A bar, take a line from B bar, and this is your enable line. So we will put it in a 3 input AND gate. So this is your Y0 output. Okay. And for Y1, what is Y1? A bar, B. So take A bar, one line from A bar, one input from A bar, another input from B, and this E. So this is Y1 output. For Y2, what will happen? y2 means A, B bar into E. So take one input from A, another from B bar, another from E. So this will give us a y2, and for y3, A, B and E. So take one input from A, one input from B, one E. So this is your y3. So what we can see here, so if enable input, this enable input is 1, then only one of the outputs starting from y0 to y3 is active for a given input, right? The output y0 is active when the output y0 will be active when both the inputs are 0. Okay, y1 is active when a0 b1, y2 is active when a1 b0, and y3 is active when both the inputs are 1, right? So this is the basic binary decoder or 2 to 4 line decoder. Alright, now we shall move on to the 3 to 8 line decoder. So as the name suggests, in the 3 to 8 line decoder, it will be having 3 inputs. So here the 3 inputs are ABC and 8 outputs starting from Y0 to Y7. Okay, so the 3 inputs are decoded into 8 outputs. Okay, so each output representing one of the min terms of the 3 input variables. This decoder is used for binary to octal conversion. 3 to 8, 8 means octal, right? So the input variables may represent a binary number and the output will represent the 8 digits in the octal number system. The output variables here are mutually exclusive because only one output can be equal to 1 at one time. As you can see here, the output line whose value is equal to 1 represents the min term equivalent of the binary number presently available in the input line. Alright. So what we can observe here, we have 3 input line ABC and output starting 8 outputs y0 to y7. So with 3 input variable we can have 8 combinations starting from 000 to 111. So when y0 is active, y0 will be active when all are 0. Then at that time all the output will be 0. y1 will be active when a0, a equals to 0, b equals to 0, c equals to 1. y2 will be active when a equals to 0, b equals to 1, c equals to 0. Likewise, y7 will be active when all the ABC are 1. So you have to first make 3 lines for your inputs. This is A line and this is A bar. This is B line, this is B bar. This is C line, C bar. So accordingly, which output is active, we have to do the connections. So y0 means A0 into B0 into C0. So A0, take one input from A0, one input from B0, another input from C0. So this is my y0. y1 means A bar, y0 is A bar, B bar, C bar. So we are taking the inputs from A bar line, B bar line and C bar line. y1 means A bar, B bar, C. So take one input from A bar, take one input from B bar, take one input from C. So we have to put it in a 3 input AND gate. Likewise, y7 is A, B, C. So take one input from A line, one input from B line, one input from C line and put it in a 3 input AND gate. Okay. So this is 3 input 3 to 8 line decoder. Alright. Now BCD to 7 segment decoder. Okay. So in this BCD to 7 segment decoder, what happens? So first let's learn about what is BCD. The BCD or binary coded decimal, it is a type of the binary code which is used to represent a given decimal number in an equivalent binary form. Okay, its main advantage is that it allows easy conversion to decimal digits for your display or faster calculations. Okay, so the most common BCD code is a 8421 BCD code. Okay, so in this BCD equivalent of a decimal number that I will show you in the next slide how it happens. First you see here, this is a BCD to 7 segment decoder. Okay, so in this type of decoder, it accepts the BCD code. Okay, and it provides, so what is a BCD code? If I write here a decimal number 14, what will be its BCD code? For 1, what is the binary representation? 0001, and 4, what is the binary representation? 0100. Okay, so this is the BCD equivalent of this decimal number. Okay, so sometimes in hexadecimal characters A through F may be also produced. Okay, so here you can see this is a letters used in the, this is a 7 segment display. Okay, 7 segment display, and in each case you can observe here, when I want to glow 0, how many here, how many bits are here? A, B, C, D, E, F and G. So based on what digit I want to display, I have to glow that particular outputs only. Okay, so suppose I want to display 0, so which bits should be glowing? A, B, C, D, E, F, then only it is presenting 0, right? 1, if I want to glow 1, that means B and C should be glowing. Then if I want to display 2, that means A, B, G, E, D, that should be glowing. If I want to display 3, means A, B, G, C, D, that should be glowing, right? If I want to display this 4, means F, G, B, C should be glowing. If I want to display 5, means A, F, G, C, D should be glowing. If I want to display 6, means A, F, G, E, D, C should be glowing. If I want to display 7, means A, B, C should be glowing. If I want to display 8, all should be glowing, starting from A, B, C, D, E, F, G, right? If I want to display 9 except E, all should be glowing, right? So this is, first, what is my job? First I have to make the truth table. Okay, first I have to make the truth table. This is my decimal number 0 to 9, and this is the corresponding binary number. Because why I have written the decimal number 0 to 9? See here, starting from 0 to 9 only I want to glow, right? Starting from all the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So starting from 0 to 9 I want to glow. So that is why you have to write the decimal numbers here, and the corresponding binary numbers, 4-bit binary numbers, we have to write here. Okay, now it is called a 8-bit 8421 BCD code. Why it is called an 8421 BCD code? If you notice over here, see, if you see for this A3 MSB, there are 8 zeros. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. Here in this column A2 there are 4 zeros. In this column A1 there are 2 zeros. In this column A0 there is 1 0. Okay, after that 1 is starting. Now why it is called 8421 code? Because of their weight. Because of their weight. See, for 9, how we are getting 9? See, A3 corresponds to 8, A2 corresponds to 4, A1 corresponds to 2, and A0 corresponds to 1. So, if you see the last row, if you observe the last row, what is there? So A3 corresponds to 8. So 1 is in 1 corresponds to this 8th position. The weight of this 1 is 8 and here it is also 1, right? So 8 plus 1 is 9. So it gives you that decimal digit 9. So here, look at here. Here 1 is here. So 1 corresponds to 8. So decimal digit 8. Here 1 corresponds to 4. This 2, this 1, 4 to 1, that means 7, that is decimal digit 7. Here you can see 0010, this one corresponds to 2, decimal digit 2. Okay, now these are my BCD inputs. These are my 7 segment outputs. So starting from A to G, all the alphabets we have to write. Okay, then in order to get this A, so in order to glow the 0, in order to glow the 0, which digits, how it should be glowing, in order to, so all these except G all should be 1, right? That you are supposed to write here, except G all should be 1. In order to glow 1, what we are supposed to do? Only B and C should be 1. Only B and C should be 1, rest should be 0. In order to glow 2, what we have to do? A, B, G, E, D. This should be 1 and A, B, G, D should be 1, rest should be 0 likewise. Okay, that is, this is how you are supposed to make the truth table first. Okay, then for each A, B, C, D, E and F, what we are gonna to do? We have to make the Carnot map. Okay, so here only for B segment the Carnot map is shown here. See, B is 1 for which decimal numbers? B is 1 for starting from 0 to 4, and again 7 to 9. So since it is a 4 variable function, we should have the 16 cells. So for B, from 0 to 4 and 7 to 9, from 0 to 0, 1, 2, 3, 4 and 7, 8, 9. Okay, 7, 8, 9. For B it is showing, right? So 0 to 4. 0, 1, 2, 3, 4. Again 7, 8, 9. This is 7. This is your 8. This is 9. Okay. This should be kept 1. Okay. Then after that 10 to 15. Since it is a BCD, right? So 10 to 15 we have to put the don't care. That is why in the cells 10, 11, 12, 13, 14, 15 we have to put the don't care. Now you just start grouping them. Okay. So this will be one group, this will be one group, this and this will be one group. So for this one, what will be my K map for this one? For this entire column, A1 bar, A0 bar, for this entire column, A1, A0, and for this one and this one, which one is not changing? A2 bar is not changing. So this is the K map for B. Okay. Similarly, we have to perform the K map for each and every segment. Okay. Then for B, this is the K map expression. So for B, this is my K map expression, because B is coming how? B is coming how? B, first we have to check B is 1 for which input combinations? A3 bar, A2 bar, A1 bar, A0 bar. So this is how these are written. We have to express in terms of the mean terms. Okay. In terms of the mean terms we have to put. So these are your mean terms, and 10 to 15 we have to put the don't care. So you will get the Carnot map representation or Boolean expression simplified form. Okay, this is how you are supposed to convert the BCD to 7 segment. Okay, all right. Next we will move on to the next part, which is my encoder. Okay, so before that I want to discuss what are the applications of the decoder. We have seen the basic operations of the decoder, right? So these decoders are used in your counter systems. They are used in analog to digital converter. Decoder outputs can be used to drive a display system also. Now this is the basic diagram of an encoder. So an encoder, it is a digital circuit that performs exactly the inverse operation of a decoder. Hence the opposite of the decoding process is called the encoding. An encoder is a combinational circuit that converts the binary informations from 2 to the power n input line to a maximum of n output line. Okay, so it has 2 to the power, you can see it has 2 to the power n input lines, and only one is active at any time and n output lines. Okay, it encodes one of the active inputs to a coded binary output with n bits, and in an encoder number of outputs is less than the number of inputs. Okay, now, first we will see the circuit of the octal to binary encoder. Octal to binary encoder. So, as we have seen that it is exactly opposite to the decoder circuit. So, in octal to binary encoder, it has 8 inputs as the name suggests. Octal to binary, 8 inputs and 3 outputs, okay, that generate the corresponding binary number. Okay, and it is assumed that only one input has a value of 1 at any given time. Okay, so how we are implementing this kind of octal to binary encoder? So octal means first we have to put the 8 inputs starting from D0 to D7. 8 inputs, 3 outputs are A, B and C. Okay, so this encoder can be implemented. First, let's see this truth table. You can see when this D0 input is active and all other inputs are 0, then the output will be, all the output will be 0. Okay. Now, if all the output will be 0, right? Now, if D1 input is active and rest of the inputs are inactive, then this C output will be equal to 1. Similarly, if D2 input is active and rest of the inputs are inactive, then B output will be 1. Similarly, if D3 input is active, then the outputs B and C will be equals to 1. If D4 input is active, then the A output will be 1. If D5 input is active, then A and C input will be 1. If D6 input is active, then both A and B output will be 1. And if D7 input is active, then all the outputs will be 1. So these encoder can be implemented with OR gates whose inputs are determined directly from the truth table. So output Z, so here ABC output you can consider as X, Y and Z. So output C or Z will be equals to 1 when it is 1. Output Z will be equals to 1 when D1 is 1, when D3 is 1, when D5 is 1 and when D7 is 1, right? Output Y or B is 1 when D2 is 1, D3 is 1, then D6 is 1 and D7 is 1. Output A or X is 1 when D4, D5, D6 and D7 are 1. Okay, so we have to represent it like this. The output C or Z, this one, the output C or Z is input D1 plus D3 plus D5 plus D7. Then output Y or B is D2 plus D3 plus D6 plus D7 and output A or x is d4 plus d5 plus d6 plus d7. Okay, so you just make, this is shown over here. First you make the 8 input lines d0 to d7. Okay, then as per the output you arrange them. X was what we got, x is d4 plus d5 plus d6 plus d7. So take line from d4, d5, d6, d7 and put it in a 4 input OR gate. Similarly for y and z also you have to perform the same expression. We have to give the inputs in a 4 input OR gate. Okay, now we will move on to the priority encoder. What is priority encoder? So priority encoder is an encoder circuit that includes the priority function. In priority encoder, if 2 or more inputs are equals to 1 at the same time, the input which is having the highest priority will take place. Okay, so here let's consider this example. So here we have considered 4 input priority encoder. This is a 4 input priority encoder. So here you can see here 4 inputs are here. So this is the truth table of a 4 input priority encoder. Okay, and in addition to the outputs A and B, the outputs are A and B, we can see a third output which is V. This is a valid bit indicator that is set to 1 when 1 or more inputs are equal to 1. If all the inputs are 0, there is no valid input and V is equal to 0. The other two outputs are not inspected when V equals to 0 and are specified as don't care conditions. Okay, so as per this truth table, the higher the subscript number, what is the subscript number? The higher the subscript number, the higher is the priority of the input. Let's say input D3 has the priority. Here input D3 has the priority because it has the largest subscript compared to D0, D1, D2 and D3, right? So regardless of the values of the other inputs, when this D3 input is 1, the output for AB is 1, 1. That means binary 3. Then D2 has the next priority level. The output is 1, 0 if D2 is 1. Okay. Then D1 is generated only if higher priority inputs are 0 and so on down the priority level. Okay. So if we observe this truth table, then what we are getting? If we observe this truth table, A equals to, see, with 4 inputs, these are my 4 inputs, right? D0, D1, D2 and D3. This is a priority encoder and these are my 2 outputs. So when all the inputs are 0 and V 0, these A and B are simply in don't care condition. When V is 1, then only this encoder is in enabled condition. So when D0 input is active, that means your output will be 0, 0. Okay. Then when D1 input is active, output will be 0, 1. Okay. Provide and D0 in this condition, we will put don't care. D0 can be either 0 or 1. When D1 input is 1, output will be 0, 1. When D2 input is 1, output will be 1, 0. At that time, D0 and D1 will be don't care. It can be either 0, it can be either 1. Okay. And when D3 input is 1, output will be 1, 1. Okay. And D0, D1, D3, D2 can either be 0 or 1. So if you look at the A column, A means we have to check that we are getting 1 for which input combinations. A means D3 plus D3 plus D3 bar D2, right? B means what? B means, So we will get all the, if you put the instead of this don't care condition, if you put all the possible zeros and one combinations, you will get all the 16 combinations. Okay, so for each output you can plot the Carnot map. Okay, for each output you can plot the Carnot map. It will be easier. So you have to check for A column for which input combinations you are getting 1, and B column for which input combinations you are getting 1. So for those particular cells you have to put the 1 and perform the Carnot map operation. So A is giving D3 plus D2, B is giving D3 plus D2 bar D1. Now these we can easily implement with a logic diagram. So D3, so B is what? D3 plus D2 bar D1. D3 plus D2 bar, we need a NOT gate here, D2 bar into D1. So these AND gate plus this is the second term of this B, and it will be odd with the first term. So this will give the B. Okay. So what is A? A is D3 plus D2. We have to get a odd operation here. Okay. And this is for A and B, right? So for V, we have to check the input combinations. Okay. So V is my D3 plus D2 and then D1 plus D0. We need a 3 input OR gate here and we will get the output V, right?